All right, here we go. We're going to do our... Oh, let me get my microphone hooked up here. There we go. That probably sounds better. So we're going to do two more of these. We did circumcenter. We did orthocenter. We started now? We've started. Now we're going to do incenter. We did centroid. Do you remember on the circumcenter? And you even had a problem. You had three problems on the homework that we just went over. That you could circumscribe a circle, right, around the triangle. Do you remember what I said? I said it only once, but I did mention it. I said on the circumcenter, it's circumference. It goes around the outside of the triangle. I said then we're going to do another one another day where the circle is where? Inside the triangle. No, we just said outside the triangle. Okay, so it's not outside the triangle. This one is inside the triangle. Which one of these do you think that you can put a circle inside the triangle? That would be the incenter because it's in the triangle. All right, circumcenter. You make a triangle that goes outside the circumcenter. You make a circle that goes outside the triangle. The incenter, you have a circle that goes inside the triangle. All right, and hopefully I'll get it to work today. We'll see. But we got to talk about one word before we do the incenter, and that would be the angle bisector. All right, so angle bisector. So what do you think bisector means? We talked about that already. We talked about a perpendicular bisector, which means it splits a side into two equal parts. What do you think an angle bisector does? Very good. Okay, you're following along. Very good. You take an angle, right, and you split the angle into two equal angles. Everybody with me on that? All right. So let's see how I'm going to do this. All right. So now we're using this other program, GeoGebra, and let's do an angle bisector first. Okay. The reason we're doing angle bisector, we're talking about angle bisector right now. Anthony, I would really appreciate it if you stop talking. Gideon, you too. So let's take a segment right here, and we're going to make an angle out of it. Boom, boom, just right there. Okay? So there's an angle, and I have a thing that says angle bisector. You can barely see it on the screen. See, it's over here on the left. If I hit angle bisector, watch what I do. I just select that side and this side, and what it's going to do, it's going to put a line that splits that angle in half. Boom, right there. Now it puts two lines. It puts this perpendicular line. I'm not really sure why they put that perpendicular line, but I can actually get rid of that perpendicular line. Watch, I go to this thing. You can't really see it. It's off the screen, but I click on this button, and then what I'm going to do is click this thing. It makes it gray over here. Boom, I got rid of it, and there we go. All right. Gavin, knock it off. Braden, stop. All right? Act like you're in an academic situation here, okay? Act like this is a big joke. So knock it off. Now, I want to show you this. Now, it looks like it splits it in half, doesn't it? But this program is pretty nice because it shows you exactly what it is. So if I come down here, and if I click on angle, and then click on this one, click on this one, it actually shows you what the angle is. It's 19.3. So if this truly is an angle bisector, what do you think this angle down here is going to be? It's going to be 19.3 as well. So let's see if it is. So I hit angle again. I hit this side. Oops. Hit angle. Hit this side of the angle. And hit this side of the angle right there. It's because I'm not hitting the side. There it goes. And now let's try it again. There it goes. And look at that. I didn't just type in 19.3. It actually is 19.3. I'm going to do something else here. I'm going to actually, let's put a point on this right there. We're going to do something else with this a little bit later on. And then I'm going to put a segment. I'm going to connect from A to D. Now I'm going to get rid of this big long line so it just looks a little bit neater. I'm going to go to this, get rid of that. There we go. That looks good. All right. Now, I think, if I did this right, if I take this and I move it, see what it's doing? See that AD? I can stretch it out a little bit if you want. If I take this, it doesn't matter how I move this angle. What's it doing? It's splitting it in half, isn't it? Okay, so what do we call AD? AD is the what? The angle bisector. It's the angle bisector, all right? Now, technically, remember the sides of an angle are raised? Do you remember that? Okay, so what do you think AD is then? It's a ray as well because it starts at A, right, and it keeps on going. Now, I know it looks like it stops right here, but this program doesn't have arrows where it shows that it keeps on going. Originally, remember it had that big long line in there? Originally, that line would have kept on going. I could have made this picture like really small, really small like this, and that line would have just kept on going and going. You'd never see the ends of it. But it just looks a little neater like this, so that's why I decided to do that. So that's an angle bisector. Everybody good with that? Okay. So what we're going to do is we're going to draw a triangle, and guess what we're going to draw on that triangle? We're going to find the what of each of the angles? The angle bisector, exactly right. And we're going to see what that angle bisector does, okay? So remember, circumcenter, what did we do to find the circumcenter? We found the... How did we find the circumcenter? We found the perpendicular bisectors, okay? How did we find the orthocenter? We found the altitudes. Now, how are we going to find the incenter? The angle bisectors. So let's make a triangle, okay? And again, it doesn't matter what kind of a triangle. I just do a triangle like this, okay? Now, what we're going to do is we're going to find the angle bisector of each of these angles, all right? So I did it before, so we'll do it. I'll tell you what. Let me slide this over so you can see my little toolbar thing. Let's slide that over. Now, oops, I moved it back again. If I click on this, it goes back. Oh, there we go. Okay. There we go. So it doesn't show all the things on the screen. On YouTube, it probably will show everything, but that's all right. I'm just going to come over here, and you still don't see it. What I can do is make this a little skinnier. I'll show you. You just, boom, there we go. And you still don't see it. I got to scooch it over. I need to make sure that screen, that projector shows everything on the screen. Forget about it. It doesn't matter because you're not doing this anyway. I'm doing it. So there's a little thing over here that says angle bisector. So I'm going to click on angle bisector. Watch. I'm going to click on this. I'm going to click on this. There's the angle bisector. I'm going to do the same thing with this. It's going to look a little messy at first, but then I'll clean it up. That's the angle bisector. You follow me? See this angle right here and this angle right here are equal? It made this angle and this angle equal, and then I'm going to do the same thing over here and here, and it made that equal. Now, that's kind of ugly looking, but what we're going to do is we'll clean it up a little bit. All right, so let me do this. Let's find this line. Let's see where that is. There it is. Okay, I got rid of this. Let's get rid of this. Let's get rid of this one. Shh. Don't need to talk so much. Just watch. All right. Now, I don't like those lines going all the way through. Technically, they are lines, so they keep on going. So what I'm going to do is I'm going to come up here and just make it a line segment. All right. So I'm going to connect from E to H, I think. Did it work? Yeah. Let's try this again. From E. Why'd that line go down like that? That's so weird. Let's go from here to here. Okay, I think it did it. And then from here to here, I think it did it. I'm not sure. And from there to there, we'll see. Oops, don't want that. All right, so now let's get rid of this line. So I'm going to come over here, get rid of that. It didn't go all the way through, but that's okay. I don't need it to go all the way. Yeah, I don't need to have it go all the way through. Oh, I know why it didn't do it, because I didn't have a point here. Let's try this again. Sorry about that. Let's do this. See, I've only done this a little bit. So I needed to put a point here. I needed to put a point here. And I needed to put a point there. Now, when I do this line segment, now it should work from E to H. I don't know why that went down like that. And then from H to J. Yeah, that's what we want. Okay, now let's do this again. Just bear with me. Let me have my fun here. And then we're going to connect those. And then we're going to connect from here to here. Again, I don't know why that line went out like that every single time. All right, now let's get rid of all these long lines right here. So if I go to algebra and then I click that, there we go. That's what I want. Click on that. Click on this. There. All right. So what did I just do? I just made the angle bisectors. Would you agree? Now, this thing right here, whoops, didn't want that. So I'm going to call it Incenter. Oops. Did I spell it right? Incenter. Yep. All right, so that's the Incenter. Everybody with me so far? Again, how did we find the Incenter? What did we do to that triangle? We found the angle bisectors, okay? I'm not going to show that these angles are equal. I showed it before when we had that single angle. But just trust me that this angle and this angle are equal. This one and this one are equal. This one and this one are equal. It makes the Incenter. Now, we have something that's true about the Incenter. Now, I'll tell you what I'm going to do. I made all those lines. I'll tell you what I'm going to do. I'm just going to get rid of them. And I'm going to keep the Incenter right there. All right, so let's get rid of that. Oops, I don't want to get rid of the Incenter. I want to keep that. I want to get rid of that. Am I getting rid of stuff? Come on, where is it? There we go. Sorry, it's taking so long. There we go. That's what I want. I'm just going to keep the Incenter there. All right. So I'll get rid of that. Take that and get rid of that one. Get rid of this one. It just to make it a lot neater and cleaner, okay, without having a million lines all around it. But I will keep the Incenter right where it is. Okay. Again, how did I find that point? I found the angle bisector. Found the angle bisector. Now, do you remember on the circumcenter, there was something that was, there was a relationship. Can't remember that word. There was a relationship between the circumcenter and the vertices. Do you remember it was equidistant? Okay. So watch this. On the incenter, and I'll tell you what, I'm going to get rid of these points as well because they're kind of getting in the way. Now watch very carefully. This incenter right here is very, very important. There's something that's unique about the incenter, and that is that it's equidistant from all three sides of the triangle. You hear what I just said? Yeah. It's equidistant from all three sides of the triangle. So that means from this incenter to this side is the same distance from this incenter to this side and this incenter to this side. But what is the distance from here to where? Is it to the vertex? Is it to here? Is it to here? Where is it? Is it to the midpoint? Yes. No, it's not. What's the distance? No, what's the distance? We talked about this the other day. What's the distance from a point? Remember the airplane? Okay. What's the distance from a point to a line? It's the perpendicular distance. You hear what I just said? Listen to me. Listen to me. Listen to me. Up here. The distance from a point to a line is the perpendicular distance. Because if I just did this, if I said, oh, the distance from the incenter to there, now that could be a different distance from here to here. Would you agree? So how do I know what the distance from this point to this line segment is? It's got to be consistent, right? I can't just say it's anywhere on here because the distances are different everywhere that I have on here. So I have to go from the incenter perpendicular to the opposite side. So let's do that. I've got a thing that says perpendicular line. What I'm going to do is click on the incenter, click on, watch, I can click anywhere on this line. What it's going to do, it's going to make a perpendicular line from the incenter to that side right there. See what it did? So what is the actual distance, though? The actual distance, and I got to put a point here for this to work. So let's put a point right there. And now I'm going to make a segment from the incenter to H. Okay? Let's get rid of this big old line right here. There we go. So that right there is the distance from the incenter to H. Now, what did this theorem say? This theorem says that the distance from the incenter is equidistant, right? It's equidistant from all three sides. So what am I going to do from the incenter to this side? Find the perpendicular. That's right. Okay, so I'm going to go perpendicular from here. Gosh, it's like I'm in 6th grade. You guys are in 6th grade. So watch, from incenter to here. See what it did? It made perpendiculars. It doesn't show the little right angle box, but that is perpendicular. This is perpendicular. So what I'm going to do is now put a point right here. Put a point. Oops, it's not what I wanted. Oh, it is what I wanted. So watch, put a point right there. That's what I want. Put a point right there. And then let's take the segment. Now this is really important what I'm about to draw right now. Okay? And then I'm going to go from here to here. And then I'm going to get rid of this. Let's see where it is. There it is. Get rid of that. There we go. Get rid of this. And then we will be good to go. There we go. Now, what I want to show you is this. Okay, the light went out. Big deal, okay? Just pay attention. So look at all three of these. Remember what I said? And if I wanted to, right, I could move this triangle around and look at all three of those little line segments that I drew. What do you think is going to be true about them? Do you think one's longer than the other? Do you think they're all equal to each other? Right, because it says it's equidistant. So all of these, from the incenter to J, we'll call it I for incenter, okay? So IJ, IH, and, well, that's an I right there, okay? Guess I could have called it something else. But anyway, from the incenter to all three of these points, okay, perpendicular, that's going to be all the same. It doesn't matter if I made it obtuse. It doesn't matter if I made it, I don't know if I can make it right. It's kind of right triangle right there. It doesn't matter if I make it acute, all right? It's going to be all the same. So just to show you that that's true, I tell you what, now let's do the circle. Let's do that first. So hopefully this works. So if I draw a circle, why? It's not that funny. Just watch, okay? You don't have to laugh every single time. So I don't know why. There it goes. That's what I wanted. It did it different yesterday. It's so weird. But watch this. You see that circle? It stays. Doesn't matter if it's obtuse. It doesn't matter if it's right. It doesn't matter if it's acute. That circle is still inscribed. We don't say it's circumscribed. We say it's... Shh. Stop commenting on everything I say. Just listen to me. So the circle is not circumscribed. What did we talk about the other day when we said it's circumscribed? It goes what? Around the triangle, doesn't it? This circle doesn't go around the triangle, doesn't go around the circumference of it. It's where? Excuse me. It's inside. Okay, so this is called the what? Incenter, because the circle is inside. If you wanted to just see if these angles truly are equal, oops, let's make it about right. Come on, there we go. I wanted to go here. So there's a thing, here it goes, distance and length, that's what I wanted. So watch this. If I click on this little segment, it says right now it's 3.4. What if I click on this segment? What should it be? 3.4. And if I click on this segment, it should be 3.4. Okay? Doesn't matter. Now, if I change the size of the triangle, what do you think is going to change those? What do you think is going to happen to those lengths? They're going to change as well, aren't they? All right? See, there's 1.92 and it changes. But if you notice, every single time, every one of those segments are the same, aren't they? All right? So that shows you, and the whole reason I put the circle on there is because what is from the incenter, give me a good geometry word, from the incenter to point J, from the incenter to H, from the incenter to I. It's of the circle. What is it called? It's the radius of the circle, okay? So all three of them are radii of the circle, correct? Can you have a circle with different values of the radius? No, you can't. So the whole reason I put the circle here is because each one of these is a radius of the circle. And the radius is not ever going to be different. So I could take this and move it around, and each one of those radii are going to be exactly the same every single time. All right? Now again, how? Let's do this. I took too long on this stuff before today, or before we started teaching today, so I kind of ran out of time to do the centroid. We'll do the centroid tomorrow, though. All right? But on this one, let's... how do you find the incenter? To find the incenter, what do? You find the angle bisectors. Okay? Now, what's true about the incenter? The incenter is equal what? Distant from the what? From the sides of the triangle. Okay? Oops. All right, so you might want to write that down in your notes so that you can look at it, glance at it, and you can see what's going on. All right? So in order to find this incenter, you find the angle bisectors. Once you found the incenter, what's true about the incenter? It's equidistant from the sides of the triangle, which means it forms a, what kind of an angle? 90-degree angle. I think I might be able to do this. I got like a minute left here, so give me a second. Let me see if I can do this. I didn't try this one yesterday, but if you hit angle, I know you don't see it, and if I hit that little segment right there, and then this one right there, sure enough, look at that. They put it on the outside. It's kind of weird, but maybe you see that? It's 90 degrees, and I could have done that for this, and I could have done that for this down here because we made it perpendicular, all right? Now, what I want you to do, I gave you the homework assignment, which, yeah, give me a sec. So I gave you a 1 to 12 to do. There may be some, I don't know which ones are incenter, and I don't know which ones are circumcenter. Okay, if I find out who threw that, you're going to get an ASD. Okay, saw paper wad fly across the floor, and somebody put their head down so they wouldn't think I saw them do it. If I see you throwing something across the room, you're going to ASD automatically. All right, I'm tired of this foolishness, so stop it. Act like you're in an academic class, please, okay? So, on the homework, it says to do 1 through 12. There might be some things with the centroid. We haven't talked about it yet, but to tell you the truth, you guys are smart enough. You could probably look at it and see how to find the centroid. It's not that hard at all, and be able to figure it out. But I want you to look for the ones that have incenter in them, and do the ones that have an incenter. And then any problems that talk about incenter or finding the stuff that we did right here, the angle bisectors, do those problems, and then I'll give you the rest of them to do tomorrow.